start really simple and then kind of build up from there. So tonight's assignment, you're going to focus on the quadratic and exponential word problems and then the radical and rational equations. Again, the other two are not required, but they are highly recommended. Okay? Give them a once over. All right, so exponential growth. Something that you need to know is the general form for an exponential growth equation. Okay? It makes life a whole lot easier if you know the formula for an exponential growth or an exponential decay. One of the big things being able to determine the difference between whether or not it is modeled linearly or exponentially is what the growth is. Okay? There was on the last quiz a question modeling, and it gave you two linear equations and it gave you two exponential equations. Okay? If it is a constant rate of change, meaning it's the same thing over and over and over, and usually it says something along the lines of like a constant rate. Okay? If it gives you a constant rate, that is a linear growth. But if they give you a rate of change as a percent, then it's an exponential growth or an exponential decay. And so you're going to use an exponential model versus a linear model. All right? So our exponential models is we have some value, some solution we're looking for, plus or minus, or 1 plus or minus the rate, and then over time. Time can be any interval. It could be months, it could be years, it could be seconds, it could be milliseconds, it could be hours, it could be days. Okay? It's whatever interval they choose. Normally when we're talking about interest, it's years. But outside of that, time can be any measurement that they choose to measure this growth. Okay? So in this case, they used T to model the years. A represents the starting amount. Okay? The starting amount. Okay? Whatever it is that you start with. If we're talking about population growth, it's the initial population. If we're talking about, you'll see these types of equations in like problems that talk about like bacteria growth. Okay, you'll have exponential growth, so it's the amount of bacteria that you started with. Radioactive decay. Okay, how much of a sample you start with. Okay, the starting amount, and then rate is your rate. It's your percent. Okay. Make sure you turn your percent into a decimal. Okay? Always got to turn your percent into decimal notations and just kind of fill in and see what matches. All right? All of these formulas are really similar, so you got to pay really close attention to the details to pick out the correct one. Okay? Making sure that your exponent is on the outside. Okay? Make sure it's on the outside of your parentheses, and we have this 1 plus or minus our rate. Okay, so 1 plus or minus our rate here. Another way that you can see this, notice how we have to have the parentheses. The exponent is done first. Sometimes they will shorten the expression, and you won't see what's in the middle here as 1 plus 0.006%. You'll see it as 800,000, 1.006. Okay, to the power of t. Sometimes we'll go ahead and do that addition. Okay, and add those together in order to get that. So you could see it either way. You need to recognize that similarity there. And if it's a rate of decay, say the population is declining by 6.6% per year, we would do 1 minus that 0.006 to get 99.004. Okay, we would do the subtraction in order to get that value in the middle. But that's our exponential equation. Percent of change, exponential, constant change, linear. All right, big difference between those two. All right, so we're stuck with A on this one. That one didn't work. Okay, because we're adding here instead of multiplying. All right, exponent laws. Exponent laws are fun. N times x to the m. We have x to the n divided by x to the m. We have x to the n to the power of m, and we have 1 over x to the n, and the nth root of x. Okay, so we have 5 major rules for exponentials. Okay, x is the base. All right, whatever the base is. N and m are 2 different exponents. Whatever number, 2, 5, 7, 16, I don't care. Okay. If we're multiplying two values that have exponents raised to the power, the bases are the same. To simplify it, we add the exponents together. Okay, whatever those two numbers are, we add them together. That simplifies the expression. If we're dividing, instead of adding, we subtract. If we raise an exponent to a power, we multiply. If we have an exponent in a denominator, we make it negative. And if we have a square root, that is a fractional exponent. The square root is a fractional exponent. Square roots are a fraction of 1/2. Third roots would be 1/3. Fourth roots would be 1/4. So whatever that index is on the radical is going to determine the denominator of the exponent. Okay? So these are our properties of exponents. We're going to use those to simplify this expression. For the most part, you have a lot of flexibility of the order that you can use them in to some degree. So you have a little bit of leeway. As long as you're following those properties and keeping track of it along the way, you're good to go. What three properties am I going to use in order to simplify this? I'm going to need the last one.
The third one.
The third one. And the fourth one. Okay, so those are the three properties I'm going to use to simplify that. Okay, which one do you want to use first? The last one? Okay, so the square root of x will turn into what? X to the what power? Well, what is n in this case? If I have a square root, what is this number assumed to be? A 2. So x to the 1/2.
Can I take a picture of that?
Can you write it down?
I'll take a picture too. I lost my paper in the package. And I don't have a next one?
That's all.
Oh. I have it.
Well, then get that out.
But what am I supposed to write it on? A paper? This is so old school. It's 2022.
Then keep track of your shot.
Oh, you're right. Can I use the pencil too?
Sure. Go for it. What am I going to use next?
The second.
Okay. So what's it going to do?
It's going to take away the fraction. So it's going
X to the negative 1/2. Let me write that a little neater. To the end. Okay. Now what? Yep. So X to the negative 1/2 times n, which is negative n over, as an n, negative n over 2. Boom. Now, interesting question here. There's a long way and an easy way. I'm going to do the long way first. Because, why not? I want to solve for x. What can I do to get rid of that radical? Square both sides. Okay? Square both sides here and here. Okay? So I end up with x minus 12 squared equals x plus 44. Alright? So now I need to expand that left side. Alright? One of the biggest mistakes is that is not equal to x squared minus 144. Okay? This is expanded as x minus 12 times x minus 12. So you need to do distributive property throughout the whole thing to expand that squared binomial. So, long story short, we end up with this. Okay, distributive property, combine like terms. X squared minus 24x plus 144 equals x minus 44. What am I going to do next in my process of solving for x? We could, but let's get everything to this side. Subtract 44 and subtract x. Okay, so that cancels, sets our equation equal to 0. X squared minus 25x plus 100. And then what do I do with a quadratic? to get rid of the radical. I didn't multiply by 2, I raised both sides to the second power.
The radical, is that the square root?
Yep. So that cancels, and that becomes squared.
Find the roots.
By factor.
The 25.
Okay. So what multiplies to give me 100 but adds to give me negative 25? Close. Negative 20, negative 5. So set both equal to 0. X equals 20 and 5. So you might be like, yay, we got 20 and 5. There's my answer. Wrong. Why?
Because if you can't get a negative square root, well, that and like.
You're really close. So when we square our radical, we introduce the possibility of extraneous solutions. That while they satisfy this quadratic, they don't fully satisfy the original equation. Okay? So we have to plug them back in order to check to see which ones work. Okay? To see which ones work and which ones don't. All right? So if I go ahead and I take 5 and I plug 5 back in, okay, I get 5 minus 12 equals the square root of 5 plus 44. So I get negative 7 equals the square root of 49. And the square root of 49 is 7. Those are not equal. 5 is extraneous. Okay? So 5 is not a solution to that equation. Okay? If I plug in 20, it's going to work. Okay? 20 will work, and I know it'll have to work because it has to be one of them. Okay? 20 is going to work. 20 is going to be my only answer. 5 is extraneous. All right? Now, faster way to do it. If you know from the start, hey, once I square these, I'm going to get extraneous answers. Or I might get extraneous answers. So whatever numbers I get, I'm going to have to plug them back in to check anyway. And since it's multiple choice, and I know I'm going to have to plug them back in to check anyway, you could skip this whole process and just use some reasoning to kind of go through your answers. Okay? So let's reset this and kind of look at what that would look like. Okay? So I'll start with my first answer. I plug in 5. And I know that it ends up not working because we literally just worked it out. Okay? Negative 7 does not equal the square root of 49. So I know that 5 is out. Right? Which eliminates both of those answer options because they include 5. And 5 is not going to give me a true statement. Okay? So now when I look at B and C, I can see, okay, well, B is 20. And C is negative 5 and 20. So no matter what, I know 20 is going to be an answer. So do I need to bother checking 20? No, just check to see if negative 5 works. Okay, quickly throwing that in. Negative 17 square root of 39. No. Leaves me with 20. Okay, so knowing the possibility of extraneous answers can save you that whole first half and just go straight into the checking the values. Now, if it was a student supplied response and it's not multiple choice, well, then sorry, you got to go through the whole thing. And you got to check for extraneous answers. Okay? And keep in mind, if you do have this as a student supplied response, because there's only one answer, they don't have to give a limitation of X needs to be, put in the larger value or the smaller value. Because 5 is extraneous, toss it out. So if you get down to 2 answers, you can't write 2 answers in the student supplied response. You can only write 1 answer. So that should also be another hint. Hey, one of these might be extra. But check them, see which one we can toss out. Okay? All right? Again, it's a race against the clock. Anything you can do to speed that up is going to help you. All right? This one's a doozy. So I've got this rational equation. If t is a solution to the given equation and t must be greater than 0, what is the value of t? So this right here tells me I'm probably going to end up with more than one answer. I want to pick the one that's positive. Okay? So I'm probably going to pick the one that's positive. Now, in order to solve, I have variables in my denominator, which makes it really difficult to solve. So I need to get rid of my denominators. How do I get rid of fractions? I'm going to multiply by our least common denominator, which in this case is t plus 1, t plus 3, and 4. All that together is our least common denominator. So that entire expression, we're going to multiply everything by all three of those. Okay? So I've got 3 over t plus 1 equals 2 over t plus 3 plus 1 over 4. All three of those terms are going to be multiplied by t plus 1, t plus 3, and 4. T plus 1, t plus 3, and 4. T plus 1, t plus 3, and 4. So when I work at this first term, and I see I have all these factors, what's going to simplify with my denominator? T plus 1. So that leaves me with 3 times 4, which is 12, times t plus 3. Okay? 3 times 4 is 12, and then I'm left with the t plus 3. I'll distribute that again in a minute, but I don't want to do too many steps at once. I'm going to do the same thing over here. What's going to cancel in my next term? T plus 3. Leaving me with 8 times t plus 1. What's going to cancel in my last term? The 4. Leaving me with t plus 1 times t plus 3. So now my fractions are gone. Now I can just distribute, combine like terms, isolate our variable. We're going to have to factor and solve for x. So we distribute 12t, thank you. All right, 8t plus, oopsies. All day, won't let me erase. Plus 8 plus t squared plus 4t plus 3. Do you have any like terms on the right side? Okay, that gives me 12t. So 12t plus 36 equals t12 plus 12t. And then 8 and 3 gives me 11. I've got 12t on both sides. What's that going to have to do? Those will cancel. All right. And then we subtract 36 to the other side. We end up with t squared minus 25 equals 0. What type of polynomial is that? Perfect square. So it factors to be plus 5. T minus 5, set both equal to 0, t equals negative 5, and t equals 5. So what's my final answer? 5.
Can you talk through real quick how you went from...
So I have a 12t on both sides. So if I combine like terms, if I subtract 12t from here, it's also going to subtract from here, cancels that out. Subtract 36 from 11 gives me negative 25, and then I just brought the t down, and since there's nothing left on one side of the equation, it's 0.
Okay, yeah.
Any other questions, comments, concerns, queries, or? That's kind of our thing for today. So you've got 2 required assignments and 2 optional ones. So you get the rest of the class time to work on that. So we're sitting at, what, 20 minutes? 15 minutes? What time do we leave? 50? That's a good amount of time. Use your time wisely. Okay? Don't waste it. Don't squander it.
So if the like anything else, plug in whatever would make it true.
Yeah. So it's saying t has to be greater than 0, so it's just saying go as the positive answer. So you would pick whatever answer makes that restriction true. Monday.